Top 25 Quality Testing Interview Questions and Answers. Quality testing plays a critical role in ensuring that products, software, and services meet required standards before reaching customers. Organizations rely on skilled quality testers to detect defects, improve performance, and maintain customer satisfaction. Preparing for a quality testing interview requires understanding testing concepts, tools, methodologies, and real-world problem-solving techniques. This interview guide is designed to help candidates confidently prepare for quality testing roles by providing commonly asked interview questions with professional sample answers. Whether you are a beginner or experienced tester, these questions will help you demonstrate analytical thinking, technical knowledge, and strong quality assurance practices. 1. What is quality testing? Quality testing is the process of evaluating a product or system to ensure it meets specified requirements and standards. The main goal is to identify defects, improve performance, and confirm that the final product functions as expected. It involves planning, designing test cases, executing tests, and reporting issues. Quality testing ensures customer satisfaction by preventing faulty products from reaching users. Testers work closely with developers and stakeholders to verify functionality, usability, reliability, and security. Effective quality testing reduces risks, minimizes costs related to failures, and improves overall product credibility and business reputation. 2. What is the role of a quality tester? A quality tester is responsible for verifying that software or products perform correctly under different conditions. Their duties include reviewing requirements, designing test cases, executing manual or automated tests, identifying bugs, and documenting results. Quality testers collaborate with developers to resolve issues and ensure compliance with quality standards. They also conduct regression, performance, and usability testing. The role requires strong analytical thinking, attention to detail, and communication skills. By ensuring product stability and functionality, quality testers help organizations deliver reliable solutions that meet customer expectations and maintain brand trust. 3. What is the difference between quality assurance and quality control? Quality assurance (QA) focuses on preventing defects by improving processes used during product development. It involves creating standards, procedures, and best practices to ensure quality from the beginning. Quality control (QC), on the other hand, focuses on identifying defects in the finished product through testing and inspection. QA is process-oriented, while QC is product-oriented. QA activities include audits and process improvements, whereas QC includes testing and validation. Both QA and QC work together to achieve overall quality management, ensuring consistent performance and minimizing production errors. 4. What are test cases and test scenarios? Test scenarios describe high-level situations or functionalities that need validation, while test cases provide detailed steps to verify those scenarios. A test scenario focuses on what to test, such as login functionality, while a test case explains how to test, including input data, expected results, and execution steps. Test cases ensure consistent testing and help maintain documentation for future reference. Properly written test cases improve coverage, reduce missed defects, and support regression testing. They also help new team members understand system behavior quickly and efficiently. 5. What is manual testing? Manual testing is the process of executing test cases without using automation tools. Testers interact with the application as end users to identify bugs, usability issues, and unexpected behavior. It is especially useful for exploratory, usability, and ad hoc testing where human observation is important. Manual testing helps evaluate visual design, user experience, and functional accuracy. Although time-consuming compared to automation, it remains essential for early-stage testing and small projects. Skilled testers use logical thinking and creativity to discover issues that automated scripts may overlook. 6. What is automation testing? Automation testing involves using specialized tools and scripts to execute test cases automatically. It is useful for repetitive tasks, regression testing, and performance validation. Automation improves testing speed, accuracy, and efficiency while reducing human errors. Common automation tools include Selenium, TestNG, and Cypress. Automated tests can run frequently during development, supporting continuous integration processes. Although initial setup requires effort and technical skills, automation saves time in long-term projects. Organizations adopt automation testing to increase productivity, ensure faster releases, and maintain consistent quality standards. 7. What is a bug or defect? A bug or defect refers to an error or flaw in a product that causes it to behave differently from expected requirements. Bugs may occur due to coding mistakes, design issues, or misunderstood requirements. Quality testers identify defects during testing and report them using bug tracking systems. Each defect includes details such as severity, priority, reproduction steps, and screenshots. Proper defect management helps development teams fix issues efficiently. Detecting bugs early reduces development costs, prevents system failures, and improves overall product reliability and customer satisfaction. 8. Explain the software testing lifecycle, STLC. The software testing lifecycle, STLC, defines structured phases followed during testing activities. These phases include requirement analysis, test planning, test case design, test environment setup, test execution, defect reporting, and test closure. Each phase has specific deliverables and goals to ensure systematic quality validation. STLC helps testers organize tasks, track progress, and maintain testing standards. Following a structured life cycle improves efficiency, ensures complete coverage, and reduces risks. It also enhances collaboration between development and testing teams for successful product delivery. 9. What is regression testing? Regression testing ensures that new changes, updates, or bug fixes do not negatively affect existing functionalities. After developers modify the system, testers re-execute previously passed test cases to confirm stability. Regression testing is essential in agile and continuous development environments where frequent updates occur. Automation tools are commonly used for regression testing because of repetitive execution. This testing type maintains product reliability, prevents unexpected failures, and ensures previously working features remain functional after system modifications or enhancements. 10. What is smoke testing? Smoke testing is a preliminary test performed to verify whether the basic functionalities of an application work correctly after a new build. It checks critical features such as login, navigation, and main workflows. If smoke testing fails, the build is rejected for further testing. This approach saves time by preventing testers from working on unstable builds. Smoke testing ensures the system is ready for detailed testing phases. It acts as a quick quality check before performing extensive functional or regression testing activities. 11. What is sanity testing? Sanity testing focuses on verifying specific functionalities after minor changes or bug fixes. Unlike smoke testing, which checks overall stability, sanity testing validates whether a particular issue has been resolved correctly. It is narrow and targeted, saving testing time while ensuring system consistency. Testers perform sanity testing before conducting regression tests. This method helps confirm that updates have not introduced new problems and that affected modules function properly. Sanity testing improves efficiency by concentrating on impacted areas instead of retesting the entire application. 12. What is black box testing? Black box testing evaluates system functionality without examining internal code structure. Testers focus on inputs, outputs, and expected behavior based on requirements. This testing approach simulates real user interaction and ensures features work correctly from an external perspective. Techniques include equivalence partitioning and boundary value analysis. Black box testing is widely used for functional, system, and acceptance testing. It allows testers without programming knowledge to validate application performance and helps ensure software meets business and user requirements effectively. 13. What is white box testing? White box testing involves examining internal code logic, structure, and implementation details. Testers or developers analyze code paths, conditions, loops, and data flows to ensure correctness. This method helps detect hidden errors, security vulnerabilities, and inefficient code structures. White box testing requires programming knowledge and is often performed during unit testing stages. It improves code quality by ensuring maximum path coverage and logical accuracy. Combining white box testing with black box testing provides comprehensive validation of both internal and external system behavior. 14. What is user acceptance testing? UAT. User acceptance testing, UAT, is the final testing phase conducted by end users or clients to confirm that the system meets business requirements. It validates real-world workflows and ensures the application is ready for deployment. During UAT, users perform tasks similar to actual operations to verify functionality, usability, and performance. Successful UAT approval indicates that the product satisfies stakeholder expectations. This phase builds confidence before release and reduces risks associated with launching incomplete or unsuitable products into the market. 15. What is performance testing? Performance testing evaluates how a system behaves under different workloads, measuring speed, responsiveness, stability, and scalability. Types include load testing, stress testing, and endurance testing. The goal is to ensure applications handle expected user traffic without crashes or delays. Performance testing identifies bottlenecks, memory leaks, and server limitations. Tools like JMeter or LoadRunner are commonly used. By improving system performance, organizations ensure positive user experiences, prevent downtime, and maintain operational efficiency even during peak usage conditions. 16. What is test planning? Test planning is the process of defining testing strategy, objectives, scope, resources, timelines, and responsibilities. A test plan outlines testing types, tools, risk management approaches, and reporting methods. It acts as a roadmap guiding the testing team throughout the project. Proper planning ensures efficient resource utilization and realistic scheduling. Test planning also helps identify risks early and establish quality goals. A well-prepared test plan improves communication among stakeholders and ensures testing activities align with business expectations and project deadlines. 17. What is a test strategy? A test strategy is a high-level document describing overall testing approaches and methodologies used in a project. It defines testing levels, techniques, tools, environments, and standards. Unlike test planning, which focuses on project-specific details, the test strategy provides organizational guidelines followed across multiple projects. It ensures consistency in testing practices and quality standards. A clear test strategy helps teams understand testing objectives, manage risks effectively, and maintain structured quality assurance processes across development cycles. 18. What is exploratory testing? Exploratory testing is an informal testing approach where testers actively explore the application without predefined test cases. Testers simultaneously learn, design, and execute tests based on experience and intuition. This method helps discover unexpected defects that structured testing might miss. Exploratory testing encourages creativity, critical thinking, and user-focused evaluation. It is especially useful when requirements are unclear or time is limited. Combining exploratory testing with formal methods improves defect detection and enhances overall product quality. 19. What is a test environment? A test environment consists of hardware, software, tools, and configurations required to execute testing activities. It replicates real production conditions to validate system behavior accurately. Components include servers, databases, operating systems, and network settings. A stable test environment ensures reliable test results and prevents false failures. Proper environment setup allows testers to evaluate compatibility, performance, and functionality effectively. Maintaining consistent environments helps teams detect genuine issues and ensures smooth transitions from testing to production deployment. 20. What is defect severity and priority? Defect severity indicates how seriously a bug affects system functionality, while defect priority determines how quickly it should be fixed. High-severity defects may cause system crashes, while high-priority defects impact business operations or customer experience. Testers collaborate with project managers and developers to assign severity and priority levels. Proper classification helps teams focus on critical issues first. Managing defects efficiently improves workflow organization, reduces project risks, and ensures important problems are resolved before product release. 21. What is boundary value analysis? Boundary value analysis is a testing technique used to identify errors at the limits of input ranges. Instead of testing all values, testers focus on minimum, maximum, and edge conditions where defects commonly occur. For example, if valid input ranges from 1 to 100, tests include values like 0, 1, 100, and 101. This method increases test efficiency while maximizing defect detection. Boundary testing helps ensure systems handle edge cases correctly and prevents unexpected failures caused by improper input handling. 22. What is equivalence partitioning? Equivalence partitioning divides input data into logical groups or classes that behave similarly. Instead of testing every value, testers select representative values from each group. Valid and invalid partitions are created to verify system behavior efficiently. This approach reduces redundant testing while maintaining good coverage. Equivalence partitioning improves productivity and saves time during testing activities. By focusing on representative datasets, testers can quickly identify defects while ensuring application functionality works correctly across different input conditions. 23. What is risk-based testing? Risk-based testing prioritizes testing efforts based on potential risks associated with different system components. Critical features with higher business impact or failure probability receive more testing attention. Testers analyze risks related to security, performance, functionality, and user experience. This approach optimizes testing resources and ensures high-risk areas are validated thoroughly. Risk-based testing is valuable when time or resources are limited. It helps organizations minimize potential losses, maintain system stability, and deliver reliable products efficiently. 24. How do you report a defect? Defect reporting involves documenting issues clearly so developers can reproduce and fix them efficiently. A good defect report includes title, description, environment details, steps to reproduce, expected results, actual results, severity level, and supporting evidence such as screenshots or logs. Clear communication prevents misunderstandings and accelerates resolution. Testers should remain objective and provide accurate information without assumptions. Effective defect reporting improves collaboration between teams and ensures faster debugging, leading to improved product quality and smoother release cycles. 25. Why do you want to work in quality testing? I want to work in quality testing because it combines analytical thinking, problem solving, and continuous learning. Quality testing allows me to contribute directly to product excellence by identifying issues before users encounter them. I enjoy analyzing systems, improving processes, and ensuring reliable performance. The role also encourages collaboration with developers and stakeholders, creating opportunities to learn new technologies and tools. By working in quality testing, I can help organizations deliver high-quality products, enhance customer satisfaction, and support successful business outcomes through dependable solutions. Quality testing is an essential function that ensures products meet customer expectations and industry standards. Successful quality testers combine technical knowledge, analytical skills, attention to detail, and effective communication. Preparing for interviews with strong conceptual understanding and practical examples significantly improves confidence and performance. The questions and answers in this guide cover fundamental and advanced quality testing concepts frequently asked by employers. By mastering these topics and demonstrating a quality-focused mindset, candidates can stand out in interviews and build a rewarding career in quality assurance and testing.